Welcome to the R Lab for Module 1. In this lab, we're going to talk about some basic commands in R. The lab is located online through the link that you've been provided, which will bring you to the page that we're looking at here. You can right-click on this page and do Save As in Windows to save the lab. You'll want to switch the .txt to .r so that R can read it. And then you'll want to save it where in the folder that you want. I'm going to hit Cancel. I've already saved the lab on my computer. A little bit of information that'll be useful. You can navigate to the book's website here. You can also locate this by searching for the title of the textbook online. There'll be some useful information material along with the book that you may want. And all the labs we're going to be used will be located here, although you'll be provided with links to them individually in your online content. Once you've downloaded R, you'll want to open up RStudio. And I've opened up RStudio here, and I've navigated to the folder that contains my lab, and I just click on it to open it up. And we're going to walk through some of the basic commands that are in R. So here is the script or the file that we've opened in R. Down in the bottom, I have a console where I can type commands and have them executed. Up here, I have a list of the environment variables, and I can have a history of commands that I've executed. And I want to open this up a little bit more. So let's go through some of the basic commands in this lab. First command we're going to talk about is just how to make a vector. So this C command stands for concatenate, and so we're going to concatenate these four values, four integers, to make a vector. And so if I hit Control Enter up top, this command gets executed down in my console window, which is down here. And you'll see from the environment variables, we've created a variable called x, and the values it contains is the vector 1, 2, 1, 3, 2, 5. If I want to print the variable x, I just type in x down in my console, and I get the variable value, the value in that variable. I can also create x. You'll notice we use this back arrow, which is an R standard way to assign this value here into that variable. I can use an equal sign instead of the back arrow. Most of the time, the equal sign and the back arrow are equivalent. You'll see I've created a vector here, 162, which work the same way the back arrow is. The back arrow is standard in R. It's useful in some cases where there's a little bit of different in functionality. You'll want to use the back arrow. So we use the back arrow as our default way of assigning values into variables. So I've created a variable x. Now I'm going to create a variable y. And I can look up here. I have x and y. And these are the values that are in my two vectors. If I want to find the length of x, I can use the command length of x. And this tells me x is length 3 and y is length 3. We can add our two vectors together. This is element-wise addition. Element-wise means it's going to go through the different elements within the vectors and add the 1 and 1 and give me a 2. It'll add the 6 and 4 and give me a 10. So let's execute that command. And we get the 2 that we expected. 6 and 4 gave me a 10. And then when you add up the 2 and 3 in the x and y, that gives me a 5. I can use the ls command, and that will tell me a list of all the variables that are in memory, x and y. I can also look up and see those. I can use the rm command that will remove variables. So now I've removed x and y, and you can see they don't exist. And when I go to list my variables in memory again, I'm told there's nothing in memory. Another way to remove everything in memory is we can execute the rn command and assign into it, tell it the list of variables we're going to remove is ls parentheses, which gives us the list of everything in memory. So let's recreate x. And what I'm doing right now is I'm using the up arrow to cycle through my previous commands. So now we've created x. Let's go back and create y. And let's create a variable called z as well. So here's my x and y and z. And now when I execute the command remove list equals ls, it's removed everything from memory. Now we're going to talk about how to create a matrix. R has a very useful functionality. If you want information on a function, you can do question and then the function. When we execute that command, we are given information about the matrix function. So let's take a look at this matrix function. So provided with a description of the matrix function and then how to use it. So it's matrix, and then these are the inputs that are going to go into the matrix function. The first input is data, which would be the data we want to put into our matrix, and then the number of rows and number of columns in our matrix, and then this by row keyword that we'll talk about in a moment. So here's how we execute that function matrix. We're going to input it into it this data. Number of rows is equal to 2, and number of columns is equal to 2. So you see we've created our matrix X up here. We're told that we have that variable X, and if we want to take a look at it down in the console, we can just type in X and we see our matrix that has 2 rows and 2 columns. You'll notice this 1, 2, 3, 4 got allocated down the first column, 1, 2, and then down the second column, 3, 4. Here's a way we can execute the same command, but slightly differently, without using these keywords. So if you know the order of the keywords and how they're assigned, you can skip writing in each of the keyword followed by the equals. So execute that command and come down here, and we see that we've created the same matrix X. Here's the command again. Now we're entering the variables indirectly together with a keyword. Here we're going to use the keyword by row equals true. And what this will do is create the matrix, but instead of going down the columns, we're going to fill in the matrix by the rows. And so here's the matrix. By row equals 2 means true, means we go across the first row and second row and so on. Now we have our vector, our matrix X. Here's a couple of mathematical operations we can do on our matrix. We can take the square root of X, and that's not a matrix multiplication type square root. That's a element-wise square root. So it takes the square root of each of the elements in X. So here's 4, square root of 4 is 2, here's 2, and here's our numerical approximation to the number 2. We can also square X, and that's an element-wise squaring of X, right? Not X matrix multiplied by itself. This command will make a list of 50 normal random variables. And so when we execute that command, we've created X, and it's a vector of length 50, populated by normal random variables. The default values for the normal random variables is a mean of 0 and a standard deviation of 1. Now, I'm going to make a vector y, and it's going to be x plus a normal random variable, and the mean is going to be 0, and the standard deviation is going to be 1. And so there's y. And if we look at y, we can see it's what we would expect. This allows us to calculate the correlation between x and y. So this computes the correlation, and it's close to 1, which is what you would expect. This next command is going to set the seed. So if we want to execute a command and get the same results multiple times, we can set the seed, and that will assign the random variable generator to give us the same results each time. So we set this seed to 1303, and let's open this up so we can see a little more. And we get these values as a random normal random variable. And if we execute that same command again, you'll see, for example, the first value 1.00 so on is different than what we got here. But if we go back and set the seed back to the 1303, this negative 1.43 so on is the same as what we got back here, negative 1.43 so on, when we had set the seed to 1303. So anytime anybody sets a seed to 1303 in R, they'll get that same variable, that same value. So set the seed to 3. Make a variable y, which is a normal random variable length 100. We can calculate the mean of y, the variance in y, and then we can take the square root of the variance in y, which gives us a standard deviation, which we can also compute with the standard deviation command. All right, so the standard deviation is the square root of the variance, as expected. Thank you very much. In this module, we've gone through some basic commands in R.